This is the third part of probability videos. We are going to talk about mean, variance, mode, and median for some of the Vera distributions. Let's start with discrete distribution. You know what it is when it is called discrete. You have p of x is equal to x, discrete random variable, and x takes the value like something like 0, 1, 2, 3. And you also know what is continuous. This is just a recap. If you have continuous random variable, the density function would be in the form of f of x, in the form of some function where x ranges from minus infinity to infinity, all real numbers. So this is discrete and continuous random variable and their corresponding distribution functions. Now, how do we find mean, variance, and other central tendencies for these two? Now let's take the discrete examples. Mean for a discrete for both continuous and discrete random variable, it's called expectation of x. The mean in this cases, in these two cases, it's called expectation of the random variable x, and it's written as with a capital E and capital X, E of x, otherwise mu. Okay, so this is the basic idea about mean. It's called expectation of x, or you can also call it as expected value of x, and it's usually written as E of x, or in simple form mu. The definition for expected value of x or expectation of x is sigma for discrete x p of x is equal to x. Okay, which means in case you have probability distribution function, say x, which is 1, 2, and 3, and if you have p of x equal to x to be say 1 over 3, 1 over 3, and 1 over 3, or something like that, then how do you find the expected value of x? This is like x, p of x is equal to x, and you need to add all of them. So the first value of x is 1, and its corresponding p probability is 1 over 3. The next one is 2, and the corresponding probability is 1 over 3. It's here. And the next one is 3, and its corresponding probability is 1 over 3. And you can simplify this: 1 over 3 plus 2 over 3 plus 1, which is 2. So the expected value, the mu, is 2. The mean is 2 for this particular question. Okay. When it comes to continuous random variable, then expectation of x would not be a sigma. It will be an integration of x, f of x dx, and this is from negative infinity to infinity. It need not be negative infinity to infinity. It will be the limits for which the function is described. Okay, so for example, let's take a function, a density function, probability density function, as x square minus x cube over 2 for the interval 0 to 2 and 0 otherwise. Okay, so actually speaking, the limits here would be only 0 to 2 for everything. So here the expected value of x would be integral 0 to 2 x f of x dx, which is integral 0 to 2 x times x square minus x cube over 2 dx, and this can be easily evaluated. It's a definite integration. If it is a complicated problem, you can even use GDC for this. So this is for expected value for, or expected value of the random variable for both discrete and continuous random variable cases. Now there are some properties for the expected value. When you are dealing with discrete random variable, you can actually find the expected value for x square, or say something like 2x plus 1, etc. Okay, how do you do this? Expected value of x square would be, in discrete, it would be sigma x square p of x is equal to x. I'm not using the i's here, I equal to 1 to n. It is optional. Now I think it is understandable that it means there are n values of x there. And in continuous case, obviously it should be from negative infinity to infinity, otherwise as defined by the question it will be x square f of x dx. Okay, this is expectation of x square. You should be careful not to equate this to this. They are not equal. Expectation of x square is different from expectation of x the whole square. In fact, expectation of x the whole square is mu square. Mu is expectation of x, whereas this is something different and this is not equal to mu square. Let me give you some examples for both the cases, discrete and continuous. Let me take this as an example for discrete random variable. This is x and this is the probability distribution for the x values given, and the expected value of x, that is e of x, would be sigma x probability of x is equal to x. And how would you do this? This is 0 times 1 over 6 plus 1 times 1 over 2 plus 2 1 over 5 plus 3 times 2 over 15, which on simplification would give you 1.3. Okay, what would be expectation of x square, which would be x square p of x is equal to x, which actually, how do you do that? This is 0 square times 1 over 6 plus 1 square times 1 over 2. So it is, this is x and this is p of x, plus 2 square times 1 over 5 and 3 square over 2 over 15. On simplification, this would give you 2.5. So you can see that expectation of x square is not equal to the expectation of x the whole square, right? Which is, this is 2.5 and 1.3 square is not equal to 2.5. We can also find something like, if it is given, you can actually find this you can separate it, expectation of x square plus expectation of 3x minus expectation of 1. Okay, so we are going to use certain properties of expected values. Expected value of x square we have just done, and this can be written like this. The 3 can come out, so you are using, actually, if you are this is the property that we have applied just now for the 3 there. The k, expected value of kx, would be k times expected e of x. I'll just start saying e of x instead of expected value of x. This is the property that we have used here. The 3 comes out. And another property is e of a constant is the constant. Okay, therefore e of 1 would be 1. Therefore this is 2.5 plus 3 times 1.3 minus 1, and you can simplify this. So we have used this property, and we have also used one more property, like, which is called plus b equals a e of x plus b. This is a combination of these two. Okay, and previously for e of x square, what we have used is, if it was e of f of x, this would be expectation of, this is sigma f of x p of x is equal to x. This is, in the place of f of x we had x square here. We used x square and we did x square p of x is equal to x. So this is another property. So there are 1 2 3 4 properties of e of x, expected value of x. The same properties can be done for continuous random variables as well. So for a continuous random variable, you will have expected value of x square would be integral x square f of x dx. And with the question that for example that I have done just now, this would be 0 to 2, 0 to 2, minus infinity to infinity in general, but for our question it is 0 to 2, x square times x square minus x cube over 2 dx. And this is here, this is the expected value of x square, and all the other formula and properties remain the same. For e of kx, e of k is k, and e of ax plus b is, all these things remain the same for continuous function as well. Only thing is, calculation should be done with integration. If e of x is equal to 0, then the event, we take the event as game. If it is a game event, then the game is called a fair game. if the expected value of x is equal to 0. If the expected value of x is less than 0, then it is an unfair game. Okay, in all other cases there is some expectations in the game. And now for finding mode and median. It's easy to find mode and median for discrete because it's the same thing that we do in statistics. Mode is the x value for the maximum frequency. That means if you have x 0, 1, 2 and p of x is equal to x, as we did this long back, 2 over 4 and 1 over 4, it's obvious that 1 is the mode because half, this is the maximum frequency for this table. So this is easy, and we do the same thing in statistics. For finding median, you write them in order, or you find the cumulative, and then you can find out which is the median. In continuous random variable, mode is the x value for the maximum of f of x. If you find maximum of f of x, then you get the corresponding x value gives you the mode. For example, for the same example that we have done just now, when f of x is equal to x square minus x cube over 2, and we assume that the function is defined in this interval. In this interval, you use your calculus and find the maximum values. X is equal to what and what. For this, which is the maximum, either you can use calculus and find f dash of x and go on with it equal to 0, or you can use GDC and find the maximum, the x value for the maximum part of the function. So for this, you will be having f dash x is 2x minus 3x square over 2 equal to 0. Therefore it is 2x minus 3x square equal to 0, and you get x is equal to 0 or x is equal to 2 over 3. Okay, x is equal to 0, and you need to check for which value of this f of x is maximum. For this, you need to go for f2 dash of x and see which is positive. So that value of x, either this or this, would be the mode of the function. Okay, what about median? Median is halfway, right? Minus infinity to infinity at a particular place. It divides the whole part into half because the total is 1. Okay, therefore minus infinity to m would be of f of x dx should be equal to half, and this m gives you the median. So you know what is f of x. Substitute the values that are given for f of x and equate the integral to half and find the value of m. It's not going to be very difficult, and in this case the minus infinity has to be substituted with a 0 because the function is defined from 0 to 2. So your m value would be somewhere between 0 and 2. And if it is not possible to do it manually, you can use GDC to solve whatever equation you are getting with m. So you need to finally find what m is, which is the median of the given probability density function. How do you find variance for both discrete and continuous? Variance notation is sigma square. So variance of x is always expectation of x minus mu the whole square. Mu is expectation of x, okay, which we have already done. So in both the cases, it would be like, if it is discrete, it would be x minus mu the whole square, p of x is equal to x. So this can be done only after finding expected value of x, which is mu. Only after finding mu you can find variance. For continuous, it is again x minus mu the whole square f of x dx integration minus infinity to infinity in general. Okay, so what happens to the variance? Okay, the variance, square root of variance of x is given a special name, standard deviation. And the notation, of course, you would have noticed that it is square root of sigma square. Therefore this notation for standard deviation is sigma. Also, there is another formula for variance of x, which is expectation of x square minus expectation of x the whole square. Just now we did that they are not equal. Actually, in fact, this is mu square. So this is another formula for finding variance of x. If you know these two values, expected value of x square and mu, you can just directly substitute in this formula instead of doing all these things. When you use this formula, variance of x for discrete would be sigma x square p of x is equal to x minus mu square separately. Or if it is in continuous random variable, this would be x square f of x dx minus infinity to infinity minus mu square. Okay, this is separate and minus mu square is separate. So this is how you have to do variance of x if you are given expected of value of x square and mu square. We have certain properties. We did it for expected value of e of x. We found some 4 properties of v of x. Now let's see what happens to variance of x. And variance of k, a constant, is 0, and variance of ax, a constant x, is a square would come out, whereas remember when it was expected value of a of x, it's a e of x, right? But here it is a square variance x. And variance of ax plus b would be a square variance of x. In case of expected value of x, it was ax plus b would be a e of x plus b, right? So you can see that it's a square variance of x in this case, in the case of variance. And that's it with the central tendencies. In the next video, we'll talk about all types of distribution functions, binomial and Poisson, etc. Bye bye.